All right. What I want to talk a little bit about are just some vignettes of some recent kinds of disasters. And it raises kind of a bunch of the issues that Tom had up on here earlier about privacy, security, and remediation. Remediation is what happens when something goes wrong and then you need to do something about it. So what I was hoping to show you, but the machine won't cooperate, is an article that was published October 24th, 2016, and probably many people here are aware of this, generally what happened, but I'll give you a few details. The headline here reads, "Hacked webcams help shut down the internet last week or being recalled." And the article goes on to say that there was a Chinese electronics company that was very successful in selling inexpensive webcams. Hangzhou Xingame, probably not pronouncing it Medi. But they were responsible for a massive distributable denial of service attack in which thousands of these devices in people's homes that had been infected with malware at a particular point in time triggered a botnet. The botnet then overloaded the domain name server from the company DYN, who was providing domain name services to GitHub, Amazon, and Twitter, and to you, and to Bob, and probably to me at home, although I wasn't on it all the time. But basically, it shut down massive U.S. service providers, including a lot of the Akamai servers who were providing services for banks and others. And what this basically was all about was this particular webcam had an open source Linux system that was powering it, and a bug was built into the access software, the password and username, so that if you typed a long username, it would take any password. And when somebody found out that they could basically get into these devices, they launched their own little robot that found these devices. It does that by going through pinging every IP address on the internet till it finds something that looks like one of these devices. So this is one example of devices that were, easily infected because they were poorly designed. But more than that, if you kind of dig back into what was going on, it's a small company. It's not your TELUS or 3Com or Siemens or somebody, GE, somebody like that, who probably would have had multiple layers of audit and various checks on the device, but it was a small company that wanted to get their product out to the market. I'm sure they didn't mean any harm, but by leaving the door open to that and finding that these are things that went into thousands of homes, it then created a vulnerability, not so much for the security and privacy of the homes, but it allowed them to launch something that created mischief on the internet. Now, put that vignette aside, and let's talk about another one. Recently, just a few weeks ago, there was an article in the news about somebody who hacked into somebody's Ring doorbell camera. And they were watching what was going on at the front door. And as the homeowner was leaving the house, they were heckling the homeowner through the audio in the doorbell, basically freaking them out, saying, making them think that they were watching things inside the house and so on and so forth, which, of course, by the way, they could have probably easily done with these webcams as well, because the whole purpose of these webcams is to capture the audio and video and put it out on the network. So once you get control of it, you could do a botnet, but you probably also can start to eavesdrop on people. I'm standing here in front of what is my computer, which is not working, but I can see it. And if you could see what I could see, there's a piece of white tape over the camera. And maybe I'm being paranoid, but when you find some of these things that end up happening to you, you start worrying about it. So those were two stories. There was a doorbell webcam and the webcam with the denial of service. Let me tell you about story number 3, and I have a number 4, and hopefully they begin to expose some of these issues. So story number three is I live here mostly in Las Vegas, but I spent most of my life in Boston. I have another home there. I don't visit it much this time of year for obvious reasons, but yeah, Bob and I both live in the same town, by the way, in the Boston area. It happens to be the center of my telecom system. So I have a open source Linux box running an open source PBX called Asterisk. People probably who are familiar with it, it's a very powerful telephone system designed, well, for anything, for business, I think mainly, but I'm using it at home. And what I find useful is I have a couple incoming phone lines that I've subscribed to from internet service providers and voice over IP providers. One of them for the home, one of them for my office, and I have some that have area code 617 area code, so I want people who are in the Boston area to call me, not to be freaked out by dialing a 702 area code, and I have some 702 numbers. Anyhow, they come into different parts of this box, and depending on who's calling, I can put white lists in, and I can put in different lines, default to ring different places. It'll ring a number of different what appear to be extensions. My phone is extension 63 on it. My wife's is 64. My son is in Singapore. He walks around with extension 65. Doesn't care where you are because it's on the internet. And you can make outgoing calls. I can dial 81 to get an outside line on 1, 82, 83, 84. Okay, well, what's this all about? It's behind a firewall. The only ports that are opened into it are the ports that should allow only audio to go in and out. You can't actually get to the dashboard to control it or reconfigure it without opening up the firewall. I thought I was pretty safe. The Asterisk box in its own right has got its own username and password, so even if you can get by the firewall through the cable modem into the home network, you still have to be able to guess that. I thought I was pretty safe. I get a bill from my voice over IP service provider for $6,000 for fraudulent calls to the Dominican Republic. What the hell is going on? I thought I got everything locked down. Well, it turns out that there is a feature of this particular box it was designed in. So a third party can call in from an outside line, dial an extension, an internal extension, like try to reach me, and then they can send a hook flash back and they get another dial tone. Once they get a dial tone, they can dial back out to anywhere in the world, like the Dominican Republic. So needless to say, that's been locked down now. But, you know, yeah, I had to pay the bill. Actually, the voice over IP service provider was fairly kind to me. They normally would, for long distance call, they would take a percentage of what the charges were from the long distance company that they used and charge me. So they only charge me their out-of-pocket costs. But I've done two things now. First of all, I removed that feature, which is the dial out. And then the other thing is I told them to block any international calls. And of course, all the local things are there. Why? Well, I don't know. Somebody said maybe you want to start it when somebody's not taking a shower because you would use up the hot water for that or something. But you're still home, so not sure what the benefit is. But here's the thing that really kind of got a kicker on me. One of the features it has is remote diagnostics, and that sounds really cool. So, you know, for those of you who have heard the term condition-based monitoring, you have in large industrial environments, you'll have motors and compressors and refrigerators that in fact, photocopy machines and other kinds of machinery that'll be actually looking at vital signs of the unit. It'll be looking like excess vibration from the motor. It'll look for temperature overloads and that sort of thing. And it'll report those either to your building management or to the external service center of the vendor. And, you know, it's kind of cool. You get a phone call saying your air conditioner, your refrigerator needs service. Before it breaks down, before you even know there's a problem. So I figured, well, maybe that's what they're using the Wi-Fi for. Well, no. It turns out it's got a self-test button on the front. You hold it down for a few seconds, and when you originally set the thing up using the Wi-Fi, you registered a phone number with it. You hold this button down, a service tech will call you up at the phone number that you registered. Wait, and ready for this, You think they're going to read this from Wi-Fi. He then tells you to take your phone that you called it on and hold it next to a little speaker that's in front of the washer dryer, and it provides a series of FSK modem tones. Apparently, I'm deadly serious. I'll show you this. That end up apparently giving them some diagnostic information and either helping you through it or deciding to send the service tech out. So it's brand new. It does a terrific job washing and drying the clothes. I'm not sure whether it's going to give me the same sort of big bill that I got from my voice over IP service provider or do some of the other stuff. But I too have a remotely controlled doorbell that will ring. Actually, it rings as a voice intercom connection. So sometimes my phone, instead of an incoming phone call, it'll say doorbell, and then I can talk to who's at the front. But what frightens me, I can also unlock the door remotely by hitting a button, and I think I may disable that capability given what's happening. So anyhow, what are these stories? Shit happens. You don't know about it until it actually does, and then you have to kind of go back and deal with it. So being aware that something can go wrong is kind of the first step. You'd like to build features and capabilities in these IoT systems that look for, to borrow a phrase from the Young Frankenstein movie, that are abnormal. Either abnormal traffic, abnormal kinds of conditions, too many incidents of activating, deactivating, this sort of thing, or out of tolerance stuff, to first of all give you some indication that perhaps you should look at something, and then you better have some means to quickly be able to remediate it. There's a concept that's fairly well known in the world of conditional access and digital rights management, where for a variety of reasons, you have to provide some sort of global secret that you hope never leaks out, so that if somebody gets that global secret, they can't turn on all the satellite television one-way boxes or that sort of thing. But they build into this various forms of remediation where that thing gets compromised. They can send a kill signal that just basically kills all the devices that are out there. They're using the old global secret and brings the next one out of the dust. So what I'm saying is there's some other domains and some other worlds which are not IoT, where people have thought about what you do with privacy, encryption algorithms, key exchange, that have yet to be understood or adopted by the people who build these IoT devices. But the issues and the problems that I've experienced, I know are just the tip of the iceberg. And the ones that are coming down the road, I can't think about or I can't anticipate, but it scares the hell out of me. So I see Bob is itching to make a comment here, and the mic goes back to him.
Okay, first, those are wonderful examples, especially the washing machine doing the FSK modem. I ran into a similar thing where it was a problem with the Comcast, and because it got a third-party DISOS modem, there was no diagnostic protocol, so they couldn't look what it is. They'd send a technician out. He couldn't, it was a mess. And these are all part of the sort of a teething problem, that we don't have an articulate, and I've got a long talk on this, understanding of connectivity, digital concepts, so we get these kludges. But this has always been true. Like your cell phones, you think these are the most sophisticated things in the world. How many of you know what a Hayes modem is? Old enough. So it had a protocol. This is a hobbyist modem with an AT command to basically put you in control mode. Guess what cell phones had? And people discovered they had the AT command internally. So there are all these things. So this is why I'm looking for sort of, right now we're recycling old technology like programming machines in complex C++ code, which is why I'm involved in a group TC53, which is JavaScript modules for these devices. So an appliance company, problem is, you take a look at LG, there's a software problem here, but it still has hardware people and hardware mentality doing it. What you really want is very cost-effective application platforms, and not necessarily operating systems, but you really want to give people tools to express what they want. My next column on communities of devices says, this goes to the comments on shared keys. security is something too complex for normal people to understand. You need a very strange person, then you don't know whether they know what they're talking about. So you want to take that knowledge and partition it out. So instead of having to have each secure connection, you want community devices. So we need to develop the technologies, tools, languages for this understanding. Also, there's Cloudflare for scaling, because we're not going to solve the DDoS problem. We're going to have to be able to withstand it and survive it. So this is going to take a while, which is why in my house, I'm willing to use a device that uses HTTP and rely on the perimeter security, but my door lock has a higher standard. So yes, you can if you do enough, you might be able to figure out how to take over my lights, but I can reboot the house and survive it. So, use it all, but be aware that you have to sort of limit your trust.
So I didn't know this session was going to be quite the cautionary tale on IoT that it's turned into. Let me ask is, how many people out here are actually working on IoT devices or something related to IoT? Okay, a number of you, right?
Are you doing it professionally or because you want to?
Well, let me just ask you about, do you have any questions? Do you have any comments or maybe even some replies back to some of the stuff we've been talking about here? Oh, they're awake. They're just trying to think about it. Oh, go ahead. Yeah. In fact, I'll come down here. Here you go.
Hello, Johan Looking, Eindhoven University. So I run a course in Eindhoven University. I think many universities do on IoT, and that I try also to sort of discriminate the different domains and the different problems that you encounter. And if you generalize a little bit from the examples that you gave, then I think we look at, I think, the home domain. For the examples, you look at the home domain. And the home domain is largely unmanaged. So if you look at an office domain or maybe a city, then in that domain, all the devices would be managed. It will also be quite important that, well, things go right and the city is not, and maybe the office or the office owner is not accountable for anything. In the home, nobody cares, right? So, and we look for the cheapest devices. So even if you have the better device that can do a lot better protocols, we will buy the cheaper one because who cares? I think that's a characteristics of this domain, and what we need there is a sort of we need transparency there, understanding what the consequences are of installation decisions, and we also need to have a managing unit or managing, say, a brain in the house. Particularly if you look at say the number of devices exceeding the number of people a lot, so then you cannot manage each and every device by yourself. So we need technology that does the management, and we need also sort of a central brain in the house, and we need transparency. It's very important.
Like a gateway maybe or something like that.
Yeah, I think a very long time ago we used the term residential gateway for connecting basically with all kinds of different technologies. But I think whatever you build there, there's a hole there. In other domains, that's taken up by by having, say, a technical department that overlooks the whole thing, by spending a lot of money to have better management software, but we don't have that in the home domain. And by extending the number of applications that we have, the extending number of devices, we increase the risk of problems.
Okay. Thank you. Do you want to say something? All right, Bob. Here you go.
Okay. One of the things I'm most proud of is killing the residential gateway. That the original idea was that all these device light bulbs are going to be called CPE, Customer Premises Equipment. They're all extensions of the phone network, just like the original phone. And the challenge we have, and the reason I interpret the internet as the best of its infrastructure, is a dynamic system where you do not have central management. There is no central point because the homes aren't hierarchical. There isn't an at-home mode. What we need is to really understand how to dynamically composite devices. And let me tell you, the smart city is a good example. There's a nice story about New York City spending a lot of money to track the trains. and it failed. Then a little later, it turns out they were able to do it cheap because you just have the data available and anybody can add a device. So instead of thinking about smart city, think about enabling infrastructure I'm talking about, and then you can have the different systems. So you might have a traffic light system, but it's not centralized along the line of, say, lights in the park or environmental monitoring. Those are all independent. By reducing the complexity, by having sort of these systems not have to all be part of one whole, I think you improve it, but it's going to take us time to learn sort of how to manage, how to define these dynamic relationships, which are defined now by software. And a device is not part of one system. It might be a shared sensor. So this is all stuff we're learning how to do, but I think the answer is going to be far more decentralized because that's really what the technology gives us. And I think it's more resilient, and you're not all or nothing boondoggles.
Do the Internet of Things will have more protocols than the Internet?
So you're probably familiar with, I'm sure everybody's familiar with the layered aspect of the open systems interconnection model. So we've got the physical layer, and then we've got the communication stuff in between. So we are talking about at least from the home to whatever is back in the cloud, the same internet protocols. But layered on top of that, we have applications. The applications have their own security, their own access, back in the cloud, and the applications have the same, have their own unique proprietary kinds of capabilities within the home. Now, a lot of the IoT applications are just local, where you maybe have devices in the home, a thermostat talking to a furnace, or, a home security camera that might be Wi-Fi connected to a place in the home where you can monitor things. It's not designed to go outside. But it's not the communications pathway, getting the bits from point A to point B, that represents the issues or the challenges, or at least not the primary ones related to security and privacy. It does affect applications cost and communications cost. So, if you're sending like alarms or fire alarm signals or that sort of thing, it only requires, a few bits per second. If you're sending video, it requires a lot more. If you're actually doing maybe condition-based monitoring, where you're looking for, vibrations, perhaps in a device, or high-frequency squeal, requires more. So there could be different bandwidth kinds of things, and of course, the connectivity can affect the cost. These devices, to make sense, have got to be very inexpensive. So maybe you don't use the same internet protocols from these devices to the first point of concentration of the home. Maybe you use some of the ones that have been developed that are more energy efficient, Bluetooth low energy, or Zigbee, or something like that.
Like 6LoWPAN?
Right.
I agree with a lot of what Stu said, but I have a little different take. Rather than layers. Rather than layers, I think of resources. So the reason I use best efforts infrastructure is you just assume this common infrastructure. And what we will have are more application protocols. So the basic protocols like TCP, UDP, that's generic. Then we have application protocols. We also have some shared protocols like this CoAP versus HTTP, which turns out to be useful for other purposes. So it's a richer set, but it's really, again, the same internet. And on the terms of bandwidth, it's a different way of thinking about it, is you dynamically discover sort of what you're capable of. So, for example, if there's an emergency and you don't have much capacity, well, send a text message. Don't say, sorry, you can't make a call at all. You adapt. So part of the responsibility is on the application to work well. If you're disconnected, you should still be able to turn on the lights. But if you're connected to the rest of the world, maybe you can get the weather and decide that it doesn't have to sprinkle the lawn. So there are more opportunities and more things to do, but it's really, what we can do with the basic capabilities.
Okay, we've got another question right here.
So my question is that since IoT devices are affecting starting from the microcontroller to the edge level to the cloud level, can we come up with like a standard testing technology that can make sure, because for example in VLSI design, we have a standard technology that makes sure that this is the how you are going to do the testing and verification, and then you are sure that your circuit is going to work. And a follow-up question to that is that yeah, security, yeah. And this, so mainly that about the security framework testing that can affect. And second question is that since we have so many hardware of the IoT, or IoT devices are since available in the market, and their hardware is getting outdated very fast. So how can we deal with this kind of a situation?
Okay, so let me respond quickly. One thing is to remember that a lot of these devices are not even physical devices, they're just software applications. So what's new is we have more transducers, like I showed you with the Shelly, that can connect to the physical world, but ultimately it's a software problem. And the problem is, what does it mean to verify and prove it's correct? Hardware, you've got a well-defined specification. Software, the test is, does it do what I want to do? And it's very ambiguous. So there's no good test for it, no exact measure of trust of things. So that's a problem. As to becoming obsolete, it's actually interesting because all your devices become obsolete, but what does it mean to become obsolete? The nice thing about software, if you get an old Windows machine, it's amazing that you can still run Windows. You can run DOS applications from 1980. We're very good at maintaining compatibility. So sometimes you get a failure, like if you have to replace your furnace periodically, so we do that. But I think the main concern is on some devices there are these denial of service attacks. But we have to become better at handling on the network, so we can't replace them all. So ultimately, it's like any device. The old device will hang around, and we just have to sort of make sure they don't do harm.
This whole idea of obsolescence, there's virtually nothing we're buying with electronics today becomes physically obsolescent. It becomes functionally obsolescent because either it doesn't do the things that you can go out and buy today as well as the stuff you go out and buy today, and so you throw it away and you buy it. But I have got a closet full of what I call technology orphans. And why are they orphans? Well, they're physically, they work particularly well. I have a $3,000 HP TV. Did anybody know that HP ever made?
Oh, they did. I remember that. That was about 7 years or 8 years ago. Yeah.
And I never took the stickers off the front, which were the marketing stickers, connect and watch movies from, and from a whole bunch of non-Netflix suppliers that no longer exist, and get help through our HP website. Well, within about a year of buying the thing, HP decided to exit the business, and all the functions with the other than just using it as a plain dumb monitor, all of a sudden disappeared. Right, that went off. Anybody know the company 3Com that had a internet appliance called Audrey?
I've got it.
I have two of them. So Audrey was a thing that you could use. It was very compact, very nicely designed, that had a web browser in it. And it also had internet radio and a variety of other functions, the ability to send email and so on and so forth. Well, I think within about 3Com acquired this company and decided that they were going to make a big deal out of this business. And they also had a internet radio called Kerbango, which was part of this acquisition. People remember that. Probably 3 months of them getting into the business and selling this stuff, they decided to completely get out of the business. And in order to use the thing, you had to basically go to their website to use most of the services except the web browser. Of course, they stopped updating the web browser, so it wasn't long before, whatever service you're trying to get into said, you need the newest version of Chrome or whatever else it is. Also, the email client in it was based upon simple mail transport protocol, SMTP, which in the beginning, the SMTP servers did not require password authentication or TLS authentication, that sort of thing. They're all open. Well, every one of the ISPs very quickly, because people were basically mismarking the send from address, to make it look as though it was coming from someone else, they locked that down. Well, it turns out the Audrey device was not capable of providing passwords and so on and so forth. So And I can tell you about my AT&T Ergo device, which was a two-way text device that operated on cellular that they decided to get out of about a week after I bought it. But the point being that when you're buying these things, even from large companies like HP, and you think a TV that you paid a lot of money for that you might expect to have lasted 11 years a while ago, may only have a lifetime of a month or so because the company stopped supporting it. Ring doorbell, Honeywell thermostat are all dependent upon the company that sells them maintaining the website and the service to service them. I have an internet thermostat, but I went out on my way to buy one that had a built-in web browser that does not use any apps or any other network functionality other than having me make an IP connection from a browser. So at least I know when I've installed the damn thing, it's probably going to last more than the commercial lifetime of the company. And I'll always be able to access it from my Windows XP machine using my old Netscape browser because that's all it requires.
I think sometimes we may have too much history.
Yeah, no, I just want to talk about it. So the term is bit rot. There are things that die in place. Nothing changes, but except the world around it. I mean, there's DivX, if everybody remembers that. There are many of these stories. No, analog TV.
No, I'm talking about the disc format.
No, but the analog. No, but analog TV. I mean, go through the phones. But one of the high problem I have, lessons I've learned, is I was using Inseon devices. Those are engineered so-so, and I've now got to replace them. One rule is make sure you know where in the wall those devices are so you can replace them. So it's a physical issue you have to deal with.
Oh, 'cause they're inside the wall.
Yes, there's someplace, and some of them I found, some of them I know somewhere I think they are. So that goes to your point of when things become up, assume things are going to die so you can replace them physically. On the other hand, my Chumby still works as a clock.
Any more questions, comments out in the audience here? I hope we're giving you lots of good questions and thoughts to ask the following panels, which we've helped to prepare the way. Yes, go ahead.
Well, it was a little bit catastrophic, this debate, because I think we are just in the beginning of the revolution, no? And we are supposedly the technical guys that...
We're the guys who know how to do this stuff.
Yeah, well, I was imagining my mother, hearing this conversation. She will never more buy consumer appliances,
Better we suffer than they do.
Yeah, but I think, frankly speaking, maybe we are a bit lost, I was wondering if we, as engineers, we are understanding what is going on,
There's really a big system. There's really a whole systems level issue going on here, and a lot of us are specialists in certain areas, right? But a lot of the issues we've got, well, first of all, it's probably not the first time they've happened, so we can learn from the past. But also some of these things are interactions between things. They have to be thought carefully through. And so it's part of how do you build whole systems that can meet the promise that they've got, that will fail gracefully. For example, I can still use my door lock even after it quits doing what it's supposed to do. It'll still open the door, with a key, right? Things like that, And assume it doesn't, well, everything rusts. Right? Yeah, so, but, can we at least make things so that the net result, and this is kind of why we all got into engineering and technology in the first place, life is better because we did this thing than because we didn't do this thing. And if you think about it, all this IoT stuff and all these connected smart things can do incredible things for our lives, both in terms of services they can provide, coupled in with some of the aging populations in many parts of the world, helping take care of elderly people and keeping them functional and able to live independently, helping to deliver, advanced medicine, maybe keeping cameras from falling over, just all the amazing things that our technology is going to be able to do. But if we want it to do that, we've got to do it right. We've got to be thinking about the big picture. That includes the life cycle. It includes building things reliably, understanding, upgrades, and, what can we do to avoid some things becoming orphans?
And they do that both self-contained as well as they download to the device known signatures of bad stuff. So as they analyze the incoming traffic, they look for heuristic kinds of aspects of it that suggest it's no good. And they also look for signatures that have actually been detected by all their other devices that are all out there in the world that they end up putting into this device. So what does this mean for the IoT? IoT for the home is going to be a very large number of small devices that are talking to each other, talking to home systems, but to really add the value, they're going to need to go outside and talk to some servers or some facilities in the outside world. And that's where the opportunity to do bad things happen. And I suggest in that, what do you call it, a gateway, an interface device, or whatever, a concentrator, that's where you're probably going to want to put some of the facilities that look for bad behaviors, that warn you of the bad behaviors, some cases block them, and when the bad behaviors do happen, it's an opportunity to go back to the manufacturer, not of the IoT device, not to the webcam, but to whoever has this gateway or this intermediate device, and fix that by downloading to it whatever is necessary to overcome the problem that happens. Call it a bug fix, call it a software update, or whatever. Bob?
Okay. First, I was just told somebody left a package at my door, and I saw a picture of it on the nest from here. So the stuff can be very useful, and I do refer to my family as the beta site. But I think I think the one solution, this is my community of things, you do need virtual communities of things, but they'll be independent of physical topology, so there's no place to put a gateway in general, because that's a hardware device when we have a software set of relationships. But we will have various, I mean, by having these community devices with a shared secret among themselves, they can implement the policies. So the Barracuda thing, if you choose to use a mail scanning service, that's an option for those problems. So there's not one global solution, but I think the different kinds of community devices and services will develop their own. And in the meantime, we'll do cautious experimenting like I do, in hopes we see patterns and learn how to do it.
I'm still worried because in the end of the day also we have a responsibility with the newer generations, and we are educators, or at least especially for us there now in Brazil, IEEE is the highly reputed society in terms of guidelines. So one challenge that eventually we can pose to this community is, why not we build a committee to foster the ethics by design recommendations for the future of this industry,
Let me give you one quick answer. Is I think the big change issue is this is not apart from society. This is the physical infrastructure for society as a whole. So the problem you face is, how do we develop ethics for society? And that's not a trivial problem. So it's not about ethics for devices. You can do that locally for some of the devices. But really, we're integrating all this technology for society. What's new is what I call radical transparency, the ability to make connection between endpoints, embed smarts. But that's so generic that it's going to take us a while to get a handle on it.
By the way, one more thing, if you're interested in standards and doing stuff like that, we just happen to have a standards meeting that's going on down in Siena, down the hall there ways. And they've got a lot of, even some IoT-related standard stuff going on there. So if you're interested in that kind of work, and maybe creating groups that could do some of this, they're right down, just down the hallway a little ways. Siena's the room. You can head on down there and chat with them about that too. So, other questions, thoughts? Yeah, we could call this early. Yeah. Anything else? Is this okay for you guys? Is this interesting? Yeah?
Did we end up discouraging anybody from either buying or entering the business? I hope not.
Well, I think that what you're saying is we should get together and we should try to fix some of these things. We can anticipate some problems, partially because a lot of us have experienced them, and can we learn from that? Can we create sort of procedures, best practices, rules, even that we can use, in ways that we work with each other between companies, the way that things work, and try to create. There's this thing, and I think I mentioned it earlier when the lady was given the talk from TELUS. She's talking about ethics. There's a whole actually the IEEE standards group came out with this really interesting document called Ethically Aligned Design, and it's a free PDF that you can go online and find this thing. And it's a lot of it's focusing on autonomous systems and the ethics of autonomous systems and that kind of stuff. But I think there's a lot of elements of that might be interesting to take a look at with regard to IoT devices, many of which, in fact, are going to have some kind of AI inference engines or things like that running in them probably as well. So anyway, some interesting things to think about. Maybe
One thing I actually should acknowledge is that this whole IT thing is being used as an excuse for terrible policies, whether evil or not you can judge. But this whole idea of smart cities, for example, where you basically make the city smarter than everybody in it as opposed to enabling infrastructure. And then the idea that you're going to pay for it by monetizing people's data. There are alternatives. So we should basically look out for corporations that are doing things, sort of taking advantage of opportunities, and not accept these stories that that there are huge flows of data through the city and that it's all got to be collected because they're going to discover great things. And sure, like looking at DNA can discover great things, but the biggest success in DNA has been asparagus. You can look up the reference.
DNA?
Basically, if you can smell asparagus in the urine.
Oh, that tells something about your genetics. Okay.
That's the short version. But, we don't need all this data. Like, if you look at it, all the data, you look at the New York skyline, all those bits are going to waste. Why is somebody capturing every view of the skyline forever? There is a useful value to forgetting. There's a useful value to accepting that we do not need every last bit. There's good engineering which says you should look at the data locally and characterize it rather than save it just in the case somebody wants to pour over it. We have that in financial laws. We have limited amounts of time. So let's push back on some of the people who take advantage of the opportunities created by IoT.
So anyway, thank you all for listening to three white-haired guys, who have closets full of old equipment in our, and I hope you have enjoyed the rest of the IoT sessions. Maybe got some interesting things to talk about there, and maybe got some ideas of things we ought to be doing that we could, take action and try to make better devices in a better future. Thank you.